Welcome. Today we'll look at one of the fundamental elements of automation and programming in general, debugging and exception handling. You'll learn how to identify bugs and other misbehaviors in your automation and the steps you need to take in order to resolve them. UiPath has a few tools that will be familiar to those of you with some coding experience, things like execution logs, breakpoints, and try-catch blocks, and a few special interaction ones like element and activity highlights. But before we jump right in, one quick but important note: an often ignored aspect of debugging automation projects is naming the actions and flowcharts in your workflow. We mentioned it in previous training videos, but today you'll see its importance beyond just having an easy-to-read workflow. And that is because, in the process of tracking down and solving different issues, UiPath will show you where an error occurred by name. As you can see, while both error messages show the problem, the one on the right gives you a much better idea of where the failure happened, which in turn helps you understand, pinpoint, and solve the problem faster. So it's a very good habit to have that will pay dividends later when your workflows and debugging jobs get increasingly complex. Right, with that noted, let's move on to our main focus, debugging. For exemplification purposes, we have here a straightforward workflow that enters some data into this sample app right after clearing all the fields. The debugging tools are here in the Execute tab, and we'll kick off the debugging process by pressing the Start Debug button. There are a few things going on at the same time, so breathe in and let's take a closer look. The most obvious one is the yellow highlight. It shows which action is currently being executed. It provides a visual feedback that's especially helpful in solving input and output issues specific to automation. These yellow activity highlights work even better in conjunction with the red element highlight, which can be activated in the options here. The red highlight indicates the effect of the current action on other applications' elements. Obviously, it only works for input or output activities because other actions have no effect outside of UiPath. Next, one of my favorite tools, the Properties Inspector. Besides various relevant properties for the active action, more importantly, it shows the current values of all variables declared in the current scope. In our case, these two dummy variables. This feature will be very useful for solving more delicate programming logic issues. And the third thing that is going on, along with the others, is the detailed log of all the actions that took place in the workflow. It provides an informative context for your write lines and log messages like this one. Most of the time, this debugging log, along with various write line or log messages, should be your first line of defense in trying to resolve unwanted behaviors. If at any time you feel like all this goes a bit too fast, you can slow it down with this handy slow step option that can be activated and deactivated even while the workflow is running. This way you can examine the workflow better, how your application responds to UiPath commands, how variables update, and so on. But most of the time you'll be interested in a particular part of your workflow. The technique for those situations is to add breakpoints using this toggle breakpoint button here. It marks a specific point in your workflow where the execution will pause. Once stopped, you can check the state of your application, the current value of variables, printed messages, and whatever else you might need. And then, when you're done, you have a few options for how to continue. You can choose to resume at normal speed by pressing Continue Debug, or take a step-by-step approach by pressing the Step Over button. And of course, resume whenever you want. Right, so these are the debugging tools UiPath puts at your disposal, so make sure you try them out the next time your workflow is not behaving as it should. Since software automation involves interacting with other applications, besides the debugging tools we just mentioned, I'd like to show you a few techniques for how to actively solve the most common interaction challenges. The first issue you might encounter is when the element you're trying to interact with cannot be found, or is wrongly identified. Either UiPath can't click on it, or it cannot get its value, or it's not doing it correctly. In order to make our workflow fail, we intentionally covered it up with a media player window that is set to be always on top. The other actions are unaffected by the obstruction, but the Clear Fields menu item cannot be clicked on the file menu that is opened, so it fails. For these types of errors, there are two things you should try. First, make sure the window you're trying to interact with is visible. UiPath can interact with apps even when they're in the background, but that is explained better in the next step. So we'll just move this window out of the way. This solves our problem, but for situations where you don't have that option, you can change the input method for the offending action down here in the action properties. You can even box select multiple actions to modify their parameters at the same time. As you might remember from the input methods training video, the default method, active when both send Windows messages and simulate are unchecked, uses the hardware mouse and keyboard drivers to imitate a human using them. That means this method should work every time if the application is in the foreground. Basically, if a human can perform the action, the default method should work. But make sure you also try the other methods because they work in the background and that might be a viable solution. Like our example here that works if we switch to simulate click and manages to clear all fields even when hidden behind another app. If after these two steps your automation still doesn't work, the next thing you should take a look at is the selector for that action. There is a whole in-depth episode dedicated to selectors, so make sure to watch that if you're having issues with them. Two possible quick fixes are indicated on screen: to refresh the selector and attach to live element. Here in the expanded selector editor window, it solves a set of issues with selectors that are too specific or that slightly change over time. It works by finding common properties between the two instances of the same element. So these few simple steps should be enough most of the time to ensure your automation runs smoothly. Make sure the application you're trying to automate is visible, change the input methods starting with the default, then check the selector to make sure it is correct. You may find that your workflow works most of the time, but sometimes fails. That could be a different type of problem. It's probably a timing issue, like some elements that are not yet loaded when UiPath tries to interact with them. Could be on the web pages or desktop applications. The approach and solutions for these kinds of problems are very similar to the ones discussed in a previous video, Advanced Image-Based Automation. So have a look at that episode if you'd like a more detailed description of the technique. We'll use the same example now too, but not in a virtual machine. The login on the SAP homepage. When this little icon is clicked, the login window pops up, but with a slight delay. Not sure if it's intentional or not, but it doesn't matter. And here is a very basic workflow that automates that. It clicks the login button and types the email and password. Now, this runs flawlessly because UiPath actually waits for the element to appear. As you should know, all click and type actions have this timeout property which specifies how long to wait for the element to appear before giving up and throwing an error. And the default, while not shown here, is 30 seconds. We'll go ahead and change that to 0, essentially disabling the waiting period for this type activity. It's an artificial way of producing an error, so I can show you how to solve timing issues in an uncomplicated environment. So now if we run, the type activity will give up looking for the text field before the pop-up actually opens and it'll fail. Good. Now how do we fix it? Well, these are the three main tools that you can use, and keep in mind that these have three identical counterparts for image-based automation. Element exists is a bit different from the other two in that it doesn't affect the running of the workflow in any way. It just returns a true or false value depending on the existence of a specific element. It can be anything: a window, a button, a pop-up message, or any other component of an application. Element exists will tell you if that element is on the screen or not. So, if we come back to our workflow and we insert element exists activity right after the click to check for the email field, it should return a false value. We just need to create an output variable to see the result. But it will actually try to find the element for 3 seconds to be exact, its default timeout, and in our case it will succeed because the pop-up opens a bit faster than that. But if we shorten its timeout to, let's say, 10 milliseconds, it will return false because the element doesn't exist yet. It will also fail because, as you can see in the output pane, the email field does not exist when the type command is being executed. If we watch a slow replay, we can even see the error message and UiPath window appear before the web page login pop-up. Now, with the element exists information, we could use an if-else decision or do-while loop to evaluate if the pop-up exists and either wait for it or do something else entirely if it's never found. And in general, you can use this method to choose your next actions based on how an application responds. Maybe it will show a certain message, or maybe another, or maybe nothing at all. Now you can act accordingly. The other two activities differ from element exists in that they stop the running of the workflow until a special condition is met. Find element stops the automation until an element is found, and wait element vanish, obviously, waits for an element to disappear before continuing. So, for a different approach to our little problem, let's reset the workflow to its most basic, a click and two type actions. If we insert a find element after the click action, it will hold the running workflow and wait for the element to appear, and when it does, it fires off the rest of the workflow. The default timeout is 30 seconds, after which it will throw an error if nothing is found. I'm sure that by now you have a pretty good idea of how wait element vanish works too, so I will let you experiment with it yourself. In more critical automation projects, you will want to be able to detect errors as they happen and perform various actions when they occur, sometimes even recover gracefully from specific failures, instead of crashing and terminating the whole workflow. A special activity for this purpose is the try-catch. It is made up of two main blocks, try and catch, and a third optional one called finally. In the try block, you will put the actions that might throw an error, and the catch block is for the actions to be executed when an error occurs. And the third one, finally, is just for actions to be performed after the try and catch blocks. You might notice that the catch block is actually called catches, plural. That is because multiple catches can be added to catch different types of errors or exceptions. System exception is the one we'll use most often because it catches all types of errors, but if you want to take different measures for specific errors, you can use any additional type. And to find the specific type of an error, simply look at the exception type field of an error message. To see how that works in practice, let's look at the previous example of logging into the SAP homepage. If some action in our sequence fails, we want to automatically recognize that error and log a message with the circumstances surrounding that exception. So, let's drag in a try-catch activity. Now, select all your existing actions and drag them inside the try block. Next, add a new catch, and for the exception, type choose system exception to catch all exceptions, and then press enter. The try block automatically collapsed to make room for the actions in the catch section. Here, you can start adding relevant actions to take place when an error in the main workflow occurs. We can add a message box to give a warning of the error, but that also stops the workflow, and maybe we don't want that. The write line action prints a message to the output pane without disturbing the running of the workflow, so we could use that. But a more appropriate solution is the log command, because that has the added advantage of writing a log file, which is more practical if you're debugging a workflow that ran unattended and want to see what happened. For the level, we'll choose warning, and for the message, we'll say an error occurred while logging in. For testing purposes, we'll go into the try section and give the click action a timeout of half a second instead of the default 30 seconds. Now, all we have to do is close the browser tab to make it fail and run the workflow. And pretty quickly it finished with the error message that we gave it. In other situations though, continuing the workflow may not be the desirable behavior, and after logging the exception, you may want to actually display the error message and stop the execution process entirely. To do that, simply add a rethrow action that will pop up the error. You might notice that this error message holds a bit more information than our log in the output pane. Actually, we do have access to that data. So, let's delete the rethrow since we don't need it anymore because we'll write its contents in the log. Just add this special keyword at the end of the log string. Exception message. So now when we run, we have a much more helpful message here in the output and also in the log files. So that is how the try-catch activity works. Simply place a set of actions in the try block, and if an error takes place, the catch block gets executed. It's pretty easy. But the really interesting part comes when you try to diagnose and find possible solutions for recovering from failures. Let's say you analyze the logs and you determined the issue is the browser application itself. It randomly crashes from time to time, taking down your automation workflow with it. One of the nastiest problems to come across. Well, the easy fix for that is simply starting the browser again, going to the correct address and resuming the workflow. So let's copy the log activity and delete this whole catch sequence. Then add an open browser action that will serve as a recovery for the one that crashed, and paste the log command back in, since it's always a good idea to log what is happening. Then go to the try block and select all the actions in it. Copy them by pressing Ctrl+C, then simply go to the catch section and paste them in the open browser activity. All that's left is the URL to go to, and we're done. Now, this whole sequence is executed when an error appears in the main try block. First, a new browser is opened, then a message is logged, and finally the login sequence is performed. Oh, well, this failed because we copied the click action with the intentionally short timeout, and it takes a few seconds for the new browser to open and load the web page. We'll just delete it. And while we're here, let's update the log message to reflect what is going on. Let's see if that worked. Great. You could actually go and make it even more robust by checking if the login was successful and decide what to do next, and so on and so forth. But I will leave you to experiment with that on your own, because I want to show you a nice trick that we'll cover more in depth in the next video, the invoke command. It's useful in keeping the, let's say, master workflow cleaner by running smaller, independent workflows. Going back to the try block, right-click the SAP login sequence and choose Extract as Workflow, and give it a name. The whole section was replaced with a call to an external workflow, SAP login, located in the current project folder. In the main workflow, this single invoke block now contains the same functionality as the sequence it replaced, so we can reuse it in the catch section too. As you can see, this makes for a much tidier workspace while being equally effective. And it works too. This brings us to the end of today's video. It was pretty dense, but featured techniques that should prove valuable in everyday automation projects, as well as in more advanced, unattended automations. You're getting very close to becoming a pro. I'll see you for the next video, Project Organization. Goodbye.